WebRTC, but hold the ice. So I'll get into what that means in a moment. But first, I want to explain to you that I will be plugging a show tonight. This is the Battle of Broken Mirrors. It's an online, interactive, immersive theater show. I said that just in time with the text. It is built using React, WebSockets, three.js, WebRTC, Terraform, all the hits, all your favorites. You can buy tickets now at mirrors.live, and you can log in with all those devices they just showed and see all these crazy characters. It's completely online, and it's built with a lot of the stuff that I'm about to show you now. So I'll have that link again at the end. I highly recommend checking this out. It's a lot of fun. And if you're into these kinds of technologies, you can see sort of like what they can do. That was not made with WebRTC. That was made with Blender. So what are we going to talk about in this talk? WebRTC. What is it? That's the first thing. We're going to go over the basics of how to get a user's camera and microphone. And then I'm going to sort of talk about how to combine WebRTC with other APIs like Canvas, WebGL, the Web Audio API, the Media Recorder API, and other things like that to make some cool stuff. I'm also going to, let me just paste these links. I'm going to do it now in Slack. Not the green room, general. There we go. Sorry, I know that you're staring at this right now. And I'll post it also real quick in here if anyone wants to follow along. What I've got in here, I've got a link to my slides, but also to some examples that you can download from GitHub. And those will be important because I'm going to go through this kind of quickly, and we're going to cover a lot of things. We're going to talk about how to get the user's camera and microphone. That's the big deal here. But then we're going to talk about how to, if you know a bit of the Canvas API or WebGL or Web Audio or the Media Recorder API, you can stack these things together like Lego bricks and make really cool stuff. And that's what we're going to sort of really get into. And this is not going to be a tutorial on any of these things in particular. So I recommend, if any of this seems interesting to you, download the GitHub stuff, and you can run it on your own computer pretty easily. So I recommend checking that out. So what is WebRTC? RTC is short for real-time communication. So things like video conferencing. There are other protocols like HTTP live streaming or MPEG-Dash, and those are good for if you're doing a Twitch stream where you want high-quality video, and you don't care if you have 5 seconds of latency. But if you're doing video conferencing where you're talking between a couple people, you might want to crunch down your video to a really low bit rate because you need sub-second latency. Otherwise, people will start talking over each other and stuff like that. And so WebRTC is all about that particular use case. It's low latency. It's also got some stuff around peer-to-peer data transfer, sort of like BitTorrent. So you can stream video from one person's browser on one person's computer to another person's browser on another person's computer with no server needed in between. And that's a pretty cool thing. It's not the way that WebRTC is used all the time, but it is one way that you can use it, and that's pretty neat. The history of it was the spec was first drafted in 2011. It was first rolled out in Chrome in 2013. You may find a lot of tutorials. Whenever you find a tutorial for WebRTC, always check the date of the tutorial. A lot of tutorials came out in 2013 and 2014. People were really excited, but they often use an old version of the API, which is now obsolete. So just be aware of that. As of 2017, it is supported by all major desktop and mobile browsers. We will get to you, iOS Safari and your weird quirks and things. And when I talk about WebRTC, I usually try and break it down into two main parts. There's the get user media part, which is the part where you get access to the user's camera and microphone, and RTC pure connection, which is the part where you send that audio and video or other data over the internet. So let's see here. The problem with a lot of tutorials on WebRTC, though, is that they're kind of like this. So they start by explaining, you got your get user media. You can get the audio and the video for the microphone and webcam, and that returns a promise, and then the promise resolves into a media stream, which is a new class that handles streaming audio and video. And if you want to get a different microphone or a different webcam, you can use enumerate devices to figure out which one you want. And I highlight this in particular because with these things alone, you can do a lot of really cool stuff. there's a ton of awesome art and other things that and interesting experiences you can create just by getting the user's camera and doing stuff with it. And that's what I'm going to cover in this talk. But a lot of tutorials then take it the next step, which is the RTC peer connection, the part where you send the audio and video to another computer. And the problem here is that you quickly leave the land of front-end JavaScript and into this alphabet soup of telecom jargon and voice over IP technology. You quickly have to learn about things like ICE agents. No, not those ICE agents. These ICE agents, the one that do internet connectivity establishment, which is how you figure out whether you're going to use stun or turn. Well, how do you figure out which one you're going to use? You're going to need to set an SDP, a session description protocol. By the way, we lied when we said that you didn't need a server for this. You'll actually need a signaling server to send that between the two participants in the video call, because you're going to need to do NAT punching. Now, what's a NAT? What's an asymmetric NAT? What's a symmetric NAT? Well, in order to understand all of that, you're going to need to understand where all the IPv4 addresses go. And then once you get through all of that, you're going to need to learn about RTP, the real-time transfer protocol. Now, does the T in RTP stand for the T in real-time or the T in transfer? Nobody really knows. But there's also RTCP, which is used for transmitting metadata along with the stream, and RTMP, which is a different protocol used by things like Twitch. And then if you get really deep, you'll find out about the session initiation protocol, SIP, which is used by a lot of video conferencing in the 2000s and can interoperate with WebRTC if you have a compatible media server. This is a nightmare. And that's why I'm going to try and save all of this nastiness for another talk. To be completely fair, you really only need this, but even that's kind of a lot. Today, we're just going to focus on the parts where you get someone's audio and video and do stuff with it. Before we get started, I want to note that your page needs to either be served over SSL, so the URL starts with https:// or it needs to be served over localhost. So if you serve things locally, you'll be fine. If you try and use an IP address, that won't necessarily work. If you want to try and serve something on your computer and access it from another computer on your Wi-Fi, you can use a .localhost name. And there's a tool called mkcert, which can help with this, but that's a whole other topic. Anyway, let's get on to the actual thing itself. So, let's see here. Oh my. Oh, I'll like it there. All right. So these are the demos. You can download these from GitHub. I posted the link in the chat as well as in Slack if you want to access it later. And we're going to start with the most basic example possible. So a little hello world. Now at this point, I'm going to take off my headphones because otherwise I'm about to start hearing myself and that'll distract me. So in this example, basically what we're doing is we've got a video element on the screen, and we're going to use navigator.mediadevices.getUserMedia. So this is the main function that we use to get someone's microphone and camera. And you pass in some options. These are called constraints. You'll hear that word if you try and look this up. You're basically saying what you want to get from the user. So in this case, audio true, video true. That means we want their microphone and we want their webcam. If you want to get more specific, you can specify a particular device. You can also say, give me video, but it must be at least 720p. Or if you're on mobile, you can say, give me video, but it has to be the selfie cam. If you look this stuff up on the Mozilla Developer Network, and I've got links in the chat, you can find out more about constraints. That's as far as I'm going to go for now, though. So get user media, it returns a promise. So you can handle it using either a .then or using async await if you want. For now, I'm just going to use .then. So if it succeeds, it returns a stream, and if it fails, it throws an error. And it can fail. Something to note about this is that when you call get user media, the user will get a little pop-up saying, hey, this website would like to access your microphone and camera, allow or block. If they allow it, then you get the stream. If they block it, you'll get an error. You might also get an error if something's wrong with their camera or their microphone. There's a lot of reasons why you might get an error, so you got to make sure that you have good error handling code. But if you're just trying things out yourself, you'll probably be fine, and you'll get back your stream. So now we get our video element. We set the source object to stream. This is different from the source attribute. This is where we're going to take an actual object, this media stream that we got back, and we're going to set it as the source for this video. And then we hit play. One other thing, again, this is a topic that would require a whole other talk, but some browsers have special policies around auto playing audio and video. WebRTC is usually an exception, meaning that if you are getting the user's camera, that can just play just fine. But if you ever have an error here, it's sometimes caused by that. An autoplay policy is something that you would want to look into if that happens. So I'm going to go take a look at my example. So here it is. There's my camera and my I don't have my audio piping out just yet, but the audio is coming through my headphones right here. Yep, I can hear myself. So that's all that it takes to get someone's camera and microphone, put it on the screen. Now you've got it on the screen, and it's in an HTML element. And just like any other HTML element, you can do things like this. Whoa, what happened here? So let's take a look at the second example. So here we're doing the exact same thing that we did before, but now we're putting some cool CSS effects on this HTML element. So we've got a blur effect, we've got a transform. So I could take away this blur effect, take away this transform. I could invert the colors with this invert 1. I could do hue rotate, and then I could increase the number of degrees and rotate around the hue circle. I've got a link for this in the chat as well. If you're unfamiliar with CSS filters, they're really cool, and they can do lots of really cool stuff. If I wanted to make something really creepy, I could do a contrast filter like this. So these are all really cool things that you can do. There's grayscale, there's lots of other ones. So definitely check these out. I will note that if you do something like this, then and then you try and do some of the sort of like piping video between things that I do elsewhere, then you will run into the fact that like these effects only apply to this element, and they do not actually like follow the video data between things. That might seem kind of like a weird thing that I'm saying there, but it'll all make sense in just a moment. So what's next? Well, you may have heard me before mention the media stream. And the media stream is one of those Lego building blocks that I was sort of talking about. So on this next page, we're going to have a video, just like we did before. And we're also going to have a canvas. So if you're familiar with the Canvas API, you can draw all kinds of things with the Canvas API. It's also the basis of a lot of the WebGL stuff. So in this case, we've got a video element right here, a canvas element, and we're grabbing the 2D context from that canvas. We're not doing any WebGL stuff in this one. Then we're going to grab their webcam and microphone, set it as the source for this video element, and start playing it. And we got this button, and when we click the button, it's going to call context.drawImage with the video element and 0, 0, that's the X and Y coordinates. It just means put it in the start in the top left corner and draw it from there. So, all right, so we got the video right here. I can hit draw image, and it will draw whatever current frame is happening in the video. And so now that means that you can take the video, take the image data from the video, and draw it to a canvas. And once you can do that, there's other things you can do as well. There's other things that you can connect together. And by the way, if any of this connecting things together gets confusing, I have a cheat sheet at the end of the slides. The slides are linked in the chat and in the Slack. So we've taken a video, we've gotten the video from the user, we're drawing it as an image to the canvas. Well, we can also take that and then take that canvas and create a data URL with the current contents of the canvas and set it as the source of an image element. So let's see what that looks like. So we're going to grab a video frame from the canvas, set it as the image over here. I'm going to grab another frame that looks like that, maybe. You might note that when I grab frames from the video, it's not changing the image. That's because when we use this function down here, toData URL, we're getting a data URI that points to the exact data that is on the canvas at that time. And it's not going to change when the canvas changes. I will need to give it a new data URI to give it whatever's currently on the canvas. Now, this is pretty cool. You can pipe things from one thing to another, but it's clearly this manual process is just not great. What if we did this? Yeah, it turns out we can actually copy things directly from an HTML video element to a canvas element and then to an image element, and it actually has like almost no latency, maybe a little bit. So this is pretty cool. The fact that you can get the user's webcam and you can use it in a canvas, or you can use it in an image, you can use it in a bunch of places. All these things are sort of interoperable and just can be piped back and forth. And if you're wondering, like, hold on, Chris, this is insane. Like, how are you doing this? Well, in my example right here, you can see that what we're doing is, just like before, we've got our video, our canvas, our context, and our image. We're grabbing the video element, we're grabbing the stream, we're playing it, we've got request animation frame, and we've got this function here, which gets called on request animation frame. That means usually about 60 times a second. And it will draw the video to the canvas context, and then take the canvas and set the image source to whatever's on the canvas, and then call itself again on the next frame. And so with that, you can have a smooth thing like this that's just has almost no latency, which is pretty nuts. But hold on, what if we took this way too far? This is the human centipede of HTML video. So we've got an HTML video element. This is one to definitely check out. I've got the code like listed for exactly what each of these things is doing. We're taking the webcam, setting it as the source for a video element, taking that video and drawing it to a canvas, taking that canvas, setting it as the data URI for an image, taking that image, drawing it to another canvas, and then get this. You can do canvas.captureStream and set it as the media stream for another video. Now, this part here, it does get a little choppy, and you can see this one's smooth and this one's kind of choppy and stuff, and that's unfortunate. But the thing to note is this, right here. Canvases have a method called captureStream. And with that, you can take the canvas and get a media stream out of it. The same kind of media stream that you can get from getUserMedia. And that means, because this is all the same kind of media stream, you can take a canvas and you can stream it over the internet as if it was a webcam. Now, the question becomes, okay, we can take a canvas, make it into a media stream. What can we put on that canvas? Well, as you've seen, we can take a video element, treat it like an image element by doing draw image. And you know what else uses image elements? three.js textures. So, hey, here I am flying around in a swirly thing. What's going on here? All right. So this is not going to be a complete intro to three.js. For that, I recommend the three.js beginner tutorial where I copied most of this code, and the three.js video texture documentation where I copied the rest of the code. So right down here, we're grabbing the user's audio and video, setting it to a video element, and then we're taking that video element and using it to create a video texture, which we're then applying to a material and then setting that on a plane and having it flip around. One thing to note about this that's kind of revealing, we still have to have a video element on the screen, this video element here. And you can see that I'm still setting the stream as the source object for this video element. And that's because you can't just take a media stream and just pipe it into, a video texture or any of the other things. You need a video element in order to sort of like interpret it. And And so the video element actually becomes kind of like one of the building blocks of this stuff. We do hide the video element so that it doesn't show up. We just want to see the canvas that three.js is painting on. If I were to take this out, you would see that like, now here's the video element here, and here's the canvas element. We need this video element, but you know, we don't want it to show up on the screen, so that's why we hide it. Because it's really just sort of there so that we can grab the frames one at a time. So we've gone through a whole bunch of stuff about video, and if you're interested in more, I've got this slide here where I show you all the things that we've just done, and each of these parts of the slide is a link to the relevant part of the MDN or the three.js docs. So if you want to get a handle on like exactly how all these things relate to each other and what the heck is going on here, this is a good way to sort of like, you can take this thing, dive deep on each of these individual things if you want. But we still need to talk a bit about the audio part. We've talked a bit about the webcam. Now let's talk about this. So what I'm going to do here is I'm going to take the microphone part of my stream and I'm going to put it into the Web Audio API. Now, again, I don't have time to go into a full tutorial on the Web Audio API. You can download this, this code if you want to check it out, and it should run on your computer. One thing about the Web Audio API now is that because of the restrictions on autoplay in browsers, many of them will not let you just create an audio context and start playing things. It has to be done in response to a click event, so you're probably going to need a button like this, unfortunately. When someone clicks this button, we get their webcam and microphone. As you can see here, I'm using the async await syntax rather than the normal promise then syntax. We're going to create an audio context. This is, if you're not familiar with the Web Audio API, the audio context is like the base, the central object of the Web Audio API. It's what you use to create everything else that you're going to use. We create an audio source using that media stream. You can also create audio sources using audio elements, but that's a story for another time. We've got a delay node and a gain node. If you want more this is the simplest effect that I could make, but if you want more information about more of this, I've got links to a demo that includes more input effects that you can put on your microphone, and I've copied everything from there. And again, I've got comments explaining sort of like what's going on here. But basically, we pipe all this together. We pipe the source node to the delay node to the gain node back into the delay node, and also the gain node to the output node. And then we take that and we set it as the source object for the audio element and hit play. And if we do that, now this is where I'm gonna have to do a bit of gymnastics here. So I'm going to stop presenting and present a Chrome tab specifically. Hold on. Where is it? Is it this one? Yes. Can you hear me? All right. You're probably hearing an echo right now. It's probably kind of annoying. But this is what the delay node does. It creates sort of an echo effect. So you can apply that to the microphone. And once you've learned how to make this kind of basic effect, all right. So the last thing that we have to talk about here is the media recorder. So this is a thing where you can take a stream right here, create a new media recorder, and you can record the stream. So let's see here. So I'm going to record a stream here. Hello, I'm recording. Hello, testing 1, 2, 3. And there we go. There's a recording of me saying that and doing a little movement. You can also download that file. The Media Recorder's API is pretty cool for this kind of stuff. And you can use this as the basis of like, you can create a thing for recording, voice takes on something if you want. There's a lot of cool things you can do with this. But the last thing we're going to do is we're going to put it all together. So, oh, what's up? Oh, you can't? Oh, okay, well then hold on. That's why, because I didn't hit share. Can you see it now? All right. So let me just go back and just show you that again. Media recorder, here it is. I'm gonna hit record. I'm recording some stuff, I'm making some movements, and then I'm gonna hit stop. And now here's a video of me doing all of that. And it has audio, but you can't hear it because I have it turned off right now. You can download that file if you want and play it back in something else. This is a really cool way to use as the basis for, like, all kinds of like voiceover recording apps and things like that. So it's a pretty cool thing because I've just told you a bunch of things that you can do with media streams. And then you can record the output, which means that for our last thing, we're going to do that. We're going to go over here. This is the 10th thing. Put it all together. Now, this is, again, one where you're going to probably want to download it and check it out yourself. But we're going to make that three.js theme with the spinning version of my video. And we're going to combine it with the echo audio effect. And with all those things together, we are then going to create a media recorder. And here's the last thing that I just want to note about media streams is that you don't need to grab them from, other functions. You can make them yourself. In fact, you can make them by, like, chopping apart other media streams. So here I'm taking the canvas element from three.js. I'm running capture stream and getting its video tracks from that media stream. And then I've got the output node from my web audio API. I'm taking that media stream and I'm running get audio tracks on that. I can combine those things together and make a new media stream and pipe that into the media recorder. And now I can do this whole thing where I'm recording some audio and video, and the video is actually just this canvas. And when I play it back, ooh, it's a little garbled. This doesn't always work perfectly with Canvas, but sometimes it does if you tune it just right. The audio, I can tell you, you probably can't hear it, but it is coming through. But yeah, so that's the long and short of it. So let me go back over here and just say that, like, I've got these slides. You can check out this thing here. I've got this also in text format if you want. And yeah, come see the Battle of Broken Mirrors. It's gonna be a lot of fun, and it's running every weekend in October. You can get tickets at mirrors.live, and you'll see all these things that I just talked about in action running in the browser. So that's all.